Hi, this is Lo-Fi. I'm going to run you through creating wheels in KSP. I did a few Twitch feeds a little while back. Been meaning to re-record because there are a few bits I missed out. Apologies if you saw the screen and the stream rather and found it a little confusing. I'm going to run through this. I'm not going to do any edits. Hopefully I'll mess something up because it's instructive to have things messed up and then fix them more than it is working straight off the bat. So up here we've got the C7 post, I think it was originally, which gives the hierarchy for some of the stock wheels. There seem to be a few questions about the game object names, so I'll just kind of run through these. Ignore the camera and the light there; they're just default Unity objects. Bounds here is this little box. What that does is it actually supports the wheel off the floor at a height before the physics engine kicks in and the wheel collider takes over to start supporting the wheel. It's not that important, but you might find that your wheels sort of bounce off the runway a little bit if you don't have it. It actually gets destroyed by the code. I'll run through how that works in a little bit anyway. Rover wheel big, you look down the list here basically. Rover wheel big is just is the object that everything in the export is a child of. It's not that important. You can remove it if you want. It's easier to leave it there, particularly if you're leaving it in Unity and you haven't broken your prefab. So if you update the model, Unity updates it all for you nicely, and you can re-export it to KSP. So base will be this little object here. It's just a piece of mesh. The suspension components here they're kind of broken into bits because there's a little module called on them which makes them look at each other longingly, so they can form the suspension. So there's several components here. There's sort of the upper arm, which in the default models is split into two bits because of the way it moves. It needs to sort of telescope a little bit because it doesn't follow the arc of a suspension arm. There are ways around that, but that's beyond the scope of the stock wheels. An important one coming up: suspension neutral point, underneath which we have steering and the all-important wheel collider. These are things you probably don't want to export from your model. They are not mesh. They are simply empty game objects that are used as transforms. So suspension neutral point, as far as I can gather, seems to be as the name implies, the default point from which the suspension extends downwards. If you have it in an odd position or an odd orientation, weird things happen with the suspension. Steering underneath, that's actually a game object that gets rotated by the code, underneath which you have wheel collider. So as it's rotated, the wheel collider gets rotated. Now it's always rotated up along the y-axis. So orientation here for all of these parts is important. The wheel collider also only ever operates in the y-axis. So I'll run through in a minute how to just create those in game. Like I say, don't export them from your 3D program, as you can end up with weird stuff happening in the export. Up next, suspension traverse. Now that's a game object that's basically all of the mesh that isn't part of the physical simulation gets moved by the code. That's basically what gets moved up and down. Underneath here, you have any of the parts in the suspension. For example, this bit here, which the suspension arms grab onto. You don't want that steering, so you just child it to suspension traverse. I believe that's called bracket right there. That little, ignore this green box. That's just part of the collision mesh. It'll be this little component here. Again, some suspension parts. So this is the lower parts of the suspension, again with lookouts to the upper parts. Now track steering, again an empty game object, not mesh, underneath which we have bits of mesh. So for example, wheel mount is probably an empty game object there. Wheel mesh is the wheel, tyre, and collision enhancer will actually be this sphere collider here. I'll run through that a little later. It's important to have that because the wheel collider only works in one direction. So if the wheels tip over beyond 90 degrees, they tend to sink through the floor because the wheel collider raycast only goes in that direction, and if it doesn't hit the floor anymore, it doesn't do anything. So that's why the collision enhancer object is there. Now, busted wheel, you see that named in the config as well. Again, it's an empty game object, probably the same as wheel mount, under which you have some mesh for, as the name implies, the broken wheel model. Now you can see it's a slightly sort of greyed colour here, which implies that it's actually not enabled. You'll find the code does all this automatically depending on whether the wheel is in a broken or a normal state. You're probably aware that Kerbals can get out and fix them, at which point it toggles between these bits of mesh. It's not required. It's a bit of a nice to have. So that's a bit of a walk through the config. Hopefully that deobfuscates it a little bit. The post here is quite good. Contrary to popular belief, you don't have to carry along with default names. Bounds, I believe, is hard coded. The rest of them, I think you can play about with config and change. So I'm just going to fire up Unity here. I've just noticed we haven't got part tools. That's an interesting one. Okay, fine. Where are my parts? Part tools 0.23. Now that sounds rather promising, doesn't it? So basically, all you need to do with part tool, I just extract that somewhere. I've probably extracted it before. There we go. So we've got part tools here. What we need to do is just drag that into Unity. Now this seems to confuse quite a lot of people. Just wait for it to import. Here's a few bits and pieces. It's mostly scripts, one of which is obviously quite important because it actually gets parts out into KSP, into the .mu format. You have to excuse me taking swigs of wine. Come on. You can download the Unity package of part tools 0.2, I think it was, and then delete them and add these over the top, but I've never found it necessary because it just works. There's not a lot you can do with them at this stage. I'll explain that in a minute. So here we have just a Unity scene. I've got here a little model that I've created for the tutorial. It was actually created in 3D Studio, but it doesn't really matter. You can use SketchUp or Blender or whatever. I'm going to just drag that into our scene here. Perfect. There we go. So we've got some interesting stuff going on there with inverted normal, but it doesn't matter. We'll just have to ignore that for the moment. That one's fine. That one's not. Oh, it doesn't matter. It doesn't matter. So what have we got? Position. It's at 0, 0, 0, 0. That's fine. Now, what you can do, you want part tools on this to export it to a game object. So what a lot of people do is just go add component, KSP, part tools, wait, okay. Set the game directory here. So we go and find our KSP directory. I think it's looking for game data, isn't it? So we set that folder, and there we go. Great, that's all working fine. So we can set the model name, or you can just set this to model, so it'll export model.mu, and set a directory. Tab out there, and we can do / Twitch wheel. Right, okay. Now, there's one fundamental problem with this. KSP calculates or sets rather, the center of mass of an object where it's where basically the part that you attach part tools is. So at this moment, if we exported this from here, you would end up with the center of mass being over here, which you don't want. So the easiest way of getting around that is to remove this, create an empty game object, and put it, we just zero everything out like so, and we'll move it to somewhere that seems kind of reasonable for our centre of mass of our wheel. Bear in mind the suspension is going to go up and down from here. KSP won't change the centre of mass as the wheel moves. It doesn't matter in practical terms particularly. So if we set that over there and set these to some sensible numbers, so let's have y minus 0.7, and this you'll find is very useful having these set up, as I'll show you later, for setting the node attach point in the config. If you know these numbers, you can just plug them straight into the config file and it will work straight off the bat. It's quite easy. I'll run through that in a minute. So minus 3.5, nice sensible brown numbers, and at that point if we call this root, add component KSP multicolor. See, I told you I'd mess some stuff up. Remove component. Part tools, that's better. So twitch wheel, great. The texture stuff, people have gone through that before. I'm not going to. I don't have any textures for this model at this moment anyway. Great, so we're actually set up. We bung this as a child of root. We're actually set up and we can export a part in KSP now, and it will show up, although it won't do anything. It needs some extra bits added to it here. So we'll go about creating some empty game objects. So this one we will call Wheel Collider, in line with the C7 tutorial. We'll clone that and we will call this suspension point, or suspension neutral point rather. And we're going to call this one suspension traverse, if I spell it right. What else do we need? Let's refer back to the master diagram, shall we? So we've got suspension neutral point, wheel collider, suspension traverse. We need steering and track steering as well. What's one? Steering. Track steering. Great. Okay, so placements. Some quite important stuff here, and some kind of funky stuff we can do with Unity to get the placements right. So they're a little bit all over the place because I just created them, and then they're actually all in the same place because I cloned them one from the other. You notice in creation they all have the default orientation, with X pointing that way, Y pointing that way, and Z pointing that way. Keep them that way. Do not rotate them. The stock module gets quite upset if you have them in odd placements and rotations, so leave them be. Again, another good reason not to have them just exported with your model and created fresh, spangling new in Unity. Don't change the scale either. So we actually want to get these somewhere around where we want the wheel. So a good trick here for a lot of them, we've got steering goes under suspension neutral point. Look back at the diagram here, and wheel collider goes underneath that. Great. Okay, now where do we want suspension neutral point? Well, the easy way to do this, temporarily just bung them under wheel and zero where they are. So that's all well and good. Actually, we've got them correct in the Y and Z, so smack in the centre wheel, that's what you want. Always model your wheels in the suspension compressed state unless you want to make life really hard for yourself. What I'd suggest doing though is actually move over to the edge of the wheel, particularly for big wheels. Now, there's several reasons for this. It tends to stop the wheel, because the wheel collider is one-dimensional, It only has a raycast which goes straight down. It does not, despite the fact that it's got a radius, which I'll show you in a minute, it doesn't actually have anything that extends in the Z or the X plane. So if you have your wheel collider over here, you'll tend to find that the edge of the wheel, if it tips left a little bit, it will tend to sort of look like it sinks in the ground. So we have a bit of a bodge, and it seems to make things very stable if we have things at the edge of the wheel, because it gives you the widest track for the actual raycast. So somewhere around there is good. Let's have that a nice round figure as well. 11.75, that sounds good to me. We don't want it underneath that object. We'll just put it straight as a child of root. We only put it under wheel just for the sake of getting it orientated in the right place. So now we've got that, add component, physics, and you want the wheel collider object. Great, okay, you can't see a lot of it now, so I'm just going to toggle the wheel mesh off, and this will be the collider. I'll show you how to do that. Aha, we have a wheel collider. Brilliant. So we've got a few things here. Mass, I'm still not really sure what that does, to be honest with you. Radius is fairly self-explanatory. The radius in actual fact only has any bearing on two things. The RPM calculation for how fast the wheel is rotating versus how fast it's moving, and it sets the minimum suspension distance travel. So if you set the suspension distance to 0, that little line's disappeared. That, by that point there, is where it's going to travel across the ground. So the suspension distance is from the central point plus the radius. In this case, I think we want about, maybe it's 1.5 suspension distance, I think, for this particular wheel. Maybe less. Let's do 1 because it makes life easy. I'll get it right. There we go. We toggle the wheel back on now. How does that look against the wheel collider? Not bad. You'll find actually that you want the wheel colliders to look very slightly bigger than the wheel. That's about perfect in actual fact. Great. I hate the perspective camera swap. I don't understand why it doesn't work like it does in the ISO view. Right. Okay, so that's great. That's got the basic properties of the wheel collider set up. So basically the wheel's going to travel down from there. From here on in, we've got some objects here. What do we want to do with them? Let's refer back to the diagram. So, suspension traverse, track steering, and we need to insert some mesh stuff underneath those. So if we go back here, track steering, what I actually do is a little trick here, zero it, because suspension traverse wants to be at the same point as suspension neutral point, steering, and wheel collider. The only exception to those is track steering. Now track steering is actually where you want your mesh to rotate from about the Y. So if we move track steering in here, we want the wheel to sort of rotate around that sort of point. And this object here actually does the steering. That's great. Brilliant. So what do we do with all of these bits of mesh? Well, we've got the mount here. That can stay where it is because that doesn't need to change at all. You've got this messed up object here. That can stay where it is as well, or you can, for the sake of clarity, that's fine. We'll lose the prefab, but that's fine. This one can be a child of that as well, because all these are going to do is rotate up and down to look at this as it moves. The top suspension component, the normals of which are flipped for some reason as well, it doesn't matter. That can be a child of that too. Now, these other pieces, we will start with this piece. Now, as I was explaining earlier, this is a part of mesh that you don't want to rotate with the steering. It wants to travel with the suspension, so we put it as a child of suspension traverse. We don't have anything else that stays with that doesn't steer, so the rest of it goes under track steering. So we've got this object here called hub that wants to be childed to track steering, because the code is going to do this with track steering. Underneath that as well, we obviously want the wheel. So when we rotate track steering, oh look, the wheel gets rotated as well. Perfect. Underneath hub, we want these three suspension components actually. Because suspension traverse is going to do this. Now ignore the fact that those bits of mesh don't follow each other. That's done with a little config trickery. So that's now as a hierarchy exactly how we want it, and you'll see it follows fairly closely what we've got over here. I can move that into the right place against it. And you see we've got our suspension neutral point, steering, wheel collider. We've got suspension traverse. He's called a bracket, I've called an axle, it makes a little difference really. We've got, oh, I've made a booby there because back steering. Told you I'd make some mistakes. That's exactly what you don't want to happen. So we move those three objects, they want to be an axle, not hub. They move up and down the suspension traverse and don't get rotated with track steering. Okay, that's a little better. Back to the diagram. I don't have a busted wheel model. Part of the artifact of the export, we can get rid of that. Mount is there. Great. Okay, we're not quite ready to do any exporting yet, because we need some colliders. And I was saying earlier about the sphere collider for the wheel to stop it falling through the floor if it gets turned on its side. So the best thing to do with that is call that collision enhancer. It doesn't matter what you call it really, as long as it's got the right component added. Remove the wheel collider from that because I don't need it. And add physics. You can use lots of different things for this. In fact, before I do that, here's a neat trick. I'm going to use a mesh collide for this because I've got, and this shows you a few more bits and pieces. Physics, mesh collider, toggle convex. You won't really see it unless we toggle wheel off. There you go. Collider, great. Now we don't actually want this to be rendered, so remove component, that as well. So it's purely a collider now. What we do want to do is scale it up a little bit. So wheel back on. So I select my root object here. Right. Okay, that looks good. So we've got a collider inside the wheel which handles, well, sort of normal physics stuff that isn't anything to do with the wheel collider. So if it tips over, it's got something to rest on. We can add some extra colliders here for the sake of simplicity. I'm going to add physics, mesh collider, convex. KSP tends to like at least one mesh collider in your model, otherwise the right click menus don't tend to work properly. So you can add capsule colliders and stuff like that, but they don't always actually activate the right click menu for you to click on in KSP, so that's a nice little gotcha to watch for. What else? We've got some layers to set actually. So collider, you'll find actually that collider just about intersects the wheel collider. Now as it is, the wheel collider is going to hit this collider and all hell's going to break loose and the wheel's going to bounce up and down like crazy. If that happens, you have not set your layers. We go to Layer Manager, and if we look in this post here, there's some notes on layers. Wheel colliders ignore. Layer 26. If we, I don't think it is. So layer 26. Wheel colliders ignore. Now this goes for any collider that intersects the wheel collider. It doesn't like having stuff on the part that isn't set to that layer, so don't do it. Great. Now we've set up our layer, we can set that there. That's brilliant. What else have we got to do? Create a bounds object. Bounds. Okay, it just wants to be under there. And we're going to have a box collider for that because that's all it needs. It's only there temporarily. So that's about all it needs to be, just to make sure that the wheel is off the floor and above where the rake car is going to hit. So KSP doesn't just decide to drop it through the floor before the physics takes hold and the wheel collider takes over. I think we're kind of ready to write our part now. So I'm just going to click right here. It's very quick because there's no textures, so ignore that. Go here, KSP, game data, Twitch wheel, and we have our Mu. Brilliant. Okay. All we need now is a config. Now, rather than write one from scratch, we'll just nick the squad one, because it's nice and easy. Parts, wheel, and what are we going to go for? I think I think this one has all of the stuff that yeah, that will do. So right, let's go set a few things up in the config file. Call this Twitch wheel, if I can spell it, and Twitch wheel.mu. Okay, the node attach. Now, do you remember me talking about what to do with node attach over here? In this case, I look at mount, for example, that's about where we want it to be. So our root object is 3.5 minus 3.5 in the x direction and minus 0.7 in the y. So in here, this is x minus 3.5 and 0.7. So this is the vector, which is fine. So it goes straight across the x direction. No y or z component. I think that'll get us where we want to get, unless I've screwed it up. We'll find out in a minute. It's not a road max at all. Twitch demo. Foundries. We'll ignore the rest of that. The attach rules are fine. I'm sure you've probably seen all of these other things a million times. These you can generally leave alone unless you're making tank steering wheel or something like that, beyond the scope of what we're doing here. The important things are wheel name. That's what gets rotated as the wheel, as the name implies. Wheel collider name. Yep, we've got wheel collider because I've followed the sort of conventional hierarchy. suspension reverse and suspension neutral point. Steering I think is hard coded, but we've got that up there anyway, that should be fine. Busted wheel, I'll delete that for the moment because I don't actually have a busted wheel model, not that it makes much difference. Now the rotate rules, these are for the wheel. You cannot change which way the steering or track steering is rotated, so don't even look at that. This is for which way the wheel mesh is rotated. So we've got, I think, our wheel, we want it to rotate around the X, so we need to change that from the stock config. So nothing in the Y direction, one in there. If you find you've got your wheels rotating backwards, just change this to -1. It's that easy. You don't need to do anything more than that. Steering curve and torque curve, other people have been through. Basically, this is the vessel speed, and that's how much the wheel's allowed to steer at that speed. So it will interpolate between those 2 points. Torque curve is the same, vehicle speed versus how much torque the is applied to the wheel collider. These things here, the lookout constraints, I'm going to leave those alone for the moment. I'll come back to those because I want to show you what happens when they're not active. Now this one is an interesting one. So what this does is it copies the rotation of one object to another. However, we need to change one of these because the S2 doesn't follow convention. So we want to copy steering's rotation, which has the wheel collider underneath it, to track steering, which has the mesh underneath it. That's because they're not actually at the same point. So that will hopefully do it. Or actually maybe not. If it messes up, it'll give us some null refs and I can run through some debugging. So if we save that right there, we've got barring textures and other stuff that aren't important right now. We've got everything we should need to have a working part in KSP. So we'll go find out. I'm just going to fire KSP up. I'll bring it over in a minute. I'll leave that there so you can have a look over it. We want to actually change these names. So susp T. I'll save this in a minute and reload it so you can see what happens. Susp T wants to look at susp B. We've got some other ones as well. They're called cell F, cell R, cell R, cell F. All these do is make sure that they're looking at each other. There are a few interesting quirks of these. Stuff that's made or has a lookout called on it will make it look, if I toggle local mode here, this probably won't work. In fact, this probably won't work at all, which is a great example actually. It makes objects look down at the Z axis and it rotates them via the Y. So these objects here are in completely unsuitable orientations, which we'll find out in a minute. Again, it wants to be looking down the Z axis and rotating around the X. So if we call the lookouts on these, they're going to go completely haywire. It's a great example. We'll see what happens in KSP. It's loaded now, so bring KSP back over here. Let's see if we got our part actually into KSP. That's going to be right at the end, isn't it? Because it's called T. There we go, Twitch demo. Perfect. So we'll just create a really simple, not that one, that'll do, to mount our wheels on. I got it wrong. Right. At least we can click on it so we know the collide is active. Back to the config. Now you'll be asking yourself in a minute, did I screw this up deliberately or do I do this regularly? I'm not going to tell you. So we'll save that. Back to KSP. Hopefully this will behave. And we'll do a dynamic reload. Right, reload the parts. Yep. Some of my parts have a lot of wheel colliders. You'll notice that, the tracks particularly. You can safely ignore the warning messages in the log about wheel colliders. By the way, it's something to do with wheel collider requires an attached rigid body to function. In KSP, the rigid body stuff's applied to the vessel rather than the part. So there we go. And it's still messed up because I need to do. Ooh, that's interesting. We've got suspension parts all over the place. Don't really care. they can stay like that for all I care. Back to the config. Now that should hopefully do it. Yeah, okay. Reload it again. Back to VAB. The amount of times I've done this. Aha, there we go. Now that's behaving like it should. Perfect. Now we'll check out F2. We don't have any double refs left yet, which is encouraging. So let's stick some batteries on this thing and go take it for a test drive, see what it does. Yes, I have modified the truss pieces to be truly massive. Cool. Brilliant. No null refs. There's the wheel colliders message. Ignore that. It's completely harmless. It's just because Unity doesn't understand the way KSP runs the rigid bodies. There you go. We have steering and aha. So the wheels work. It brakes. Yeah, great. And it's kind of stuck. There we go. It's coming back down. So we now have a look at the parts of these parts, and they look awful because the normals are flicked as well. Such is life. I'll probably do an edit in a minute, fix those, and show them how they're going to work properly. If I go back to the Space Center, you'll notice that it's kind of flipping over. There's a few other bits about the wheel colliders I need to explain. So, spring strength. This is a tricky one. My wheels all have adaptive suspension settings, so you can change all this. Default value here, probably about 1.5 is about right. These are arbitrary values that don't really have any basis in real life. Damper, about a tenth of the spring value seems to work well. Target position, always have it 0. That's to do with the position along this line that it tries to make the wheel collider move to. 0 is the bottom, 1 is the top. I never really played about with that, so I don't know exactly what it's supposed to do. These are important and confusing values. So this is the value of grip you get at maximum before the tyre starts to slide. 20,000 is a ridiculous value. For these wheels, probably about 100 is good. and half of that for the value when it starts to slip seems to work pretty well. The stiffness factor is just a multiplier for these. We'll leave it at 1 for this case, and for the sideways slip we can set them the same. And you'll see in a minute how much better this makes them behave. So we'll go to write this again, back to KSP, 12, and it's going to misbehave and chuck me straight into the pointless administration building, whatever it is. I don't know why it does that sometimes. Back to our vehicle. There we go. Take the brakes off. And isn't that better? So it's not trying to flip over immediately now, or maybe it is. It's quite a light vehicle for that, for those kind of powerful wheels, but as you can see, it works fairly well. And we can drive around a bit. All is good. Great. I'm going to do a quick edit now, and I'll sort out all of these crazy suspension components, bung it back into Unity, and you'll see what happens. If I stop that there, I save my conflict. I did actually. Click in Unity here. There's a boo-boo. So actually, most of these aren't going to work because I've missed the fact that there's a capital S on most of these. If I change this quickly before I do the edit. Okay. There's all over the shop. Actually, and rod R F F Seal F. I think that's right. So if we look at rod F, which object is that? That one. That wants to look at cylinder F. Cylinder R, rod R, suspension top, suspension bottom. Perfect. Is that all we've actually got? Yeah, I think it is. I'll save that there. Back to KSP, back to the Space Center. Okay. And we've got suspension joints all over the place that are doing absolutely nothing sensible because their axes aren't aligned. So I will go and do an edit, go fix that, probably fix some of the fix up a better vessel for this size of wheels because that's ridiculously light, and I'll be back in a few minutes. And we're back post edit. Okay, I've made a few modifications here. I've actually cheated a little bit, and what I've done is I've added 2 pieces of mesh to one object. The important thing here, rotate here, is the orientation. Notice I've got it Unity in local mode at the moment. The lookout controller makes things rotate around its x-axis, looking down the z. This object here, the z-axis, is aligned to this object here, and it's going to rotate around the x-axis, and the same is true for these 2 parts here as well. I haven't modified much else, to be honest with you. This is all as it was. We can hit right there. I've got KSP and I've reloaded it. the parts here, just checking the log. Great, made a bit of a heavier rover to give you some idea of the suspension worky bits. I'll launch that right now. Another thing to look at in the config file is the crash tolerance, the braking force, and the braking force. Now this is not braking as in terms of brakes, B-R-A-K-E. This is to do with how much torque you have to apply to the part against the vessel to break it off. Similarly with braking force and crash tolerance. An interesting thing here as well in the wheel module, impact tolerance. This defines at what point the wheel, or how much force you have to apply to the wheel to make it brake, and then make the Kerbal have to get out of the vehicle to go and fix it. For the purposes of this, that's far too low for big wheels, so I'm going to change it upwards. And overspeed damage probably wants to be about 30. I will demonstrate pre-saving the config here. We've got working wheels in here, and you can see the suspension move. Now, can you see that all screwing up there? And the wheels behave absolutely abominably. A little bit like the TR2Ls, actually, just worse. There's a really, really good and very simple reason for that. I go back to Unity here. This object is far too big. This collider here. It wants to be smaller than it wants to be smaller than the wheel collider's radius. Otherwise, what happens is it catches along the ground, the wheel collider doesn't do its work, and Unity simply crashes that collider into the terrain. So always make it smaller. It's another good reason really not to get tempted just to slap a collider on the wheel mesh. You get that horrible sticking. If I write that now, back to KSP, back to the Space Center. Hopefully it hasn't broken the wheels already because their impact tolerance is set quite low. We'll do a reload. Going to behave itself this time. And back to our wheels. Now, I might have to go back to the VAB and back in, but we'll see how they behave. Oh, much better. There we go. You see they're absolutely fine now because the wheel collider is doing their work. Now what's happened here is, oh, I've just crashed it into the floor anyway. What's happened there is they broke, and as there was no busted wheel model, they've kind of continued working. The suspension distance has gone to 0 and they're busted. So I've got this all changed up here and here. That should really have been the point at which they, the busted wheel object, if we look in here, if I'd had one, that busted wheel object would have been enabled. This one would have been disabled. We'll skip over that because frankly I couldn't be bothered with the busted wheel model for the demo. Back into the SPH, grab our vehicle up again. There we go. Lovely. And we've got some workable wheels, and they steer and they go pretty fast too. And you can see all the suspension working, all the lookouts doing their thing, and they glide nicely around and function pretty well. That's pretty much it. There's not a lot more to it. Most of it from that point is just a bit of finesse in the config. Play around, have fun, and go create something cool. Cheers.